Doing well. We're gonna go back to talk about to start with our second tutorial. So I think you already know what we have spoken about previously in our first tutorial. Now we wanna go and move on to the second tutorial. In the second tutorial, you are asked to do the following exercise for these two constraining commodities. Use OLS to estimate the demand equation 1. So we wanna estimate equation 1, the demand equation 1, with using OLS. Okay, and we need to find the 95% confidence interval for the income and on elasticities. So let's go back and look at the demand equation. Okay, so if I want to take just a screenshot of this, and let's look into this. Now we know that this equation over here that you can see is basically the demand equation. And we are asked to to estimate this. So just let's remember, what does xt here represent? Xt represent the real expenditure. So in our case, for the data, because we were using food, so this represent log of food. Okay, and pt here, what does it represent? It represent p food, or and to your case you can say p cat. And this thing over here, the qt, will represent q food or q cat food, and yt here will represent your dpi. Remember that dpi stands for your income. So you can see here over here that your dpi, just gonna write dpi here, so your disposable personal income. So having said this, and we know that what each and every variable stand for, what we need to do now is to use TSM to run this. So we're gonna press on linear regression, and here I already we select OLS, and we select the dependent variable. So our dependent variable is gonna be log food, because it's taking the logarithmic, as you can see over here. And the other thing we want to say is that we want to go to type 1 select regressors. We press on intercept. If it's not pressed, please double press on it, because we have the beta node here, as you can see. And later on, what we have to do is log pcat or log pfood. So this is one of your dependent variables. The other is log qfood, which is beta q, log qt, which is log qfood, and plus beta y dpi. So we look at the dpi here, and we look at the log dpi. This is what we want, and then we hit go. So here you can see that we have the following observations. We have the t ratios here. Here is the intercept. This is estimated variable. This is the estimated variable for the log dpi. Where is the log dpi? It's beta y. So this is beta y. This is p food, which is which stands for beta p, and the other thing is log q food, which is stand for the beta q. Okay, and this is the t ratio. This t ratio is very important for part B of the question, but the second thing we want to do is to look on the confidence interval. Okay, now that we have done this, we have to remember what the question is asking us. The question is asking us to so we want to use the OLS estimation for the demand and determine the 95% confidence interval for each of the betas, which is the income, which the income in our case stands for beta y, and on price elasticities, which stands for beta p. Now, speaking about this, the first thing we want to remember is what do we mean by confidence interval, and this will take us some time just to discuss about it. So I'm going to use a sketchpad. I'm going to delete this. When we talk about, the previous t-test that we used to do, right? The t-test for the regression. What we used to say is that t-test is given by beta hat. So it could be 1, 2, whatever, but in our case it's going to be p minus beta hat This is the beta hat that we are assuming. So it's under the null hypothesis that beta p is equal to some parameter. Let's say it could be like 3 or whatever, right? Divided by the standard error of beta p hat. Okay, this will give us in the t distribution. The t distribution, if you just remember with me, the t distribution looks something like so. So if you want to plot it down, the t distribution looks somehow similar to a normal distribution. So it is symmetric. As you can see, it is symmetric with respect to the y-axis. And the other thing we want to know is when we are talking about confidence intervals, we have to understand where are we going to accept the null, which is this null, and where are we going to not accept it, which is going to be beta alternative, or beta p is not equal to 3. Now obviously here I'm saying 3, but here I'm testing it for 0, but this could be 3, right? If we just do any certain shift, it will be 3. So having said this, it is important that we want to find some, rejection rule. So if the coefficient, our beta hat, turns out to be somewhere, or the t-test, this t, which is a shifting, as you can see, and somehow scaling, it turns out to be somewhere between a certain confidence. So let's say we're going to be creating this confidence, and we say that this is, if our t turns out to be either in this region, let me change the color just, if our t-test t value turns out to be in this region or that region, what we say is that we reject the null hypothesis in favor of the alternative. Otherwise, we're going to accept the null hypothesis, which is beta is equal to 3. So what we want to do is we look up at this value, okay? And we want to find this t test, right? So we look at this t's. Let's say that we go to the tables and we check the t of, usually the p-value is the area under these two critical values. So this is t alpha over 2. I'm going to say why it is the case. And this is t alpha over 2, but this is symmetric, so we just multiply by a minus sign. Alpha stands for the probability. So the probability that this value t in absolute value is below t alpha over 2, and this represents the area underneath these curves, and this is equal to alpha. So when we talk about the absolute value of t is lower than t alpha over 2, then this represents alpha. Having said this, it is important to note that usually in practice we choose alpha to be 0.05, which is a 5% confidence. Okay, this is what we know about the p-value. No, it's not the p-value, but it is the probability that of rejection. If the p-value turns out to be that it is smaller than 0.05, then what do we say? We reject the null hypothesis in favor of the alternative. Yeah, so that was mainly the main point. But we also have to remember, we need to speak about the confidence interval. So the confidence interval is when the absolute value of t turns out to be, sorry, this should be greater. I'm sorry, I did a mistake over here. This should be greater than, not smaller than. So greater than t alpha over 2. So when we talk about this t in absolute value, so it should be smaller than t alpha over 2, right? So this means that t is between minus t alpha over 2 and t alpha over 2. Now how to find t alpha over 2 is really dependent on the data, and we're gonna go through this right now in TSM. So t alpha over 2 depends on alpha. So in our case, alpha is 0.05. And the other thing, which is, this is known as a critical value, by the way. T alpha over 2 is known as a critical value. The other thing it depends on is the degrees of freedom. The degrees of freedom, in this case, is going to be n minus the number of parameters. So in our case, it's going to be 4 parameters, so n minus 4, including the intercept. So this will be our degrees of freedom. So if we know the degrees of freedom and we know the value, the critical value, the p-value that we're going to be rejecting the null accordingly, we can easily find the critical value. And we're going to do this right now in TSM. The other thing is that I want to go really through this in more details. Okay, so I'm gonna erase a little bit. So let me erase everything. And let's talk about this. So we know that t should be between t alpha over 2 and minus t alpha over 2. This means that t, which is equal to beta hat p minus beta p over the standard error of beta hat p, is between t alpha over 2 and t alpha minus t alpha over 2. If you multiply both sides by standard error, what you're gonna get is the following. So I'm gonna call this, just for simplicity's sake, sigma, okay? But I know what sigma is referring to. So it's gonna be sigma times t alpha over 2, and this sigma could be easily observed by running the OLS estimation, minus sigma t alpha over 2, and then you just simply multiply everything by minus sign. So it turns out to be that we have beta p minus beta p hat is equal to sigma t alpha over 2, and then we have it here as minus sigma t alpha over 2. And then we add the beta p. So beta p hat is going to be beta p hat plus sigma t alpha over 2, and beta p hat minus sigma t alpha over 2. This will be our confidence band. So basically what this is saying is that if we want to find the 95% confidence interval, because here alpha is chosen to be 0.05, this means that p beta, the true parameter, the true coefficient, should belong to this interval, which is beta hat p minus sigma t alpha over 2 into beta p hat plus sigma t alpha over 2. So this will be the band in which beta p, which is a true parameter, would belong to. So I hope this makes some sense, and if you have any questions, please write them down as a comment, and I hope I can answer all your questions. Thank you. Okay, so now that we know what we mean, I just want to point some examples out. I want to put some to make some things more clearer. Remember we spoke about the t-test. So the t-test looks something like so. So if we wanna draw the t-test, the t-distribution, it looks like. Remember that the probability under all this curve. Remember that the probability that x belong to a certain number, it is r, right? So it is 1. So the probability that x is smaller than infinity or some number, it is what? It is 1. So this means that all the area that is between that is underneath the probability density function is equal to 1. I think this is well explained with Professor Namyoon. So I'm not gonna dwell into the details. It's just that the probability under all the distribution is equal to 1. Now, having spoken about this, I want you to remember that if we want to remember that t-distribution, this is gonna be what we said about that. This is gonna be the. I'm sorry, the thing I have here is very bad, but basically what we want to say is the following. We want to say that since the p over here that we have over here is the probability that we are in the acceptant region. This region is known as the accepting region, right? So the region of acceptance. Okay, region of acceptance. This is a region of acceptance. We said that this is t alpha over 2 minus, and this is t alpha over 2. And we said that the probability that, the confidence, the 95 confidence interval of beta p will be the interval which is belong to I, where I is the interval between what and what. We said that it is going to be between beta hat p minus sigma t alpha over 2 into beta hat p plus sigma t alpha over 2. So let's go to